In today's video, we're going to look at dealing with integrals that have trigonometric functions. And so this video is just going to consist of mostly examples, because when dealing with integrals that have trigonometric functions in the integrand, or specifically or only trigonometric functions, we just make use of trig identities. All right, so we're going to start by looking at the antiderivative of cosine cubed times sine. Well, this one is fairly straightforward. All we're going to do is say, let u be cosine. Right? This would mean that du is negative sine of x dx. Right? So this is a simple change of variable. Of course, what we get then is cosine cubed sine x dx is negative antiderivative u cubed du. Simple power rule, this is negative u to the fourth over 4 plus a constant. And so we wind up with negative cosine to the fourth x over 4 plus a constant. Next, let's take a look at antiderivative of cosine to the 8th x times sine to the 5th x. So to evaluate this one, notice that what we can do is rewrite sine to the 5th as sine to the 4th times sine. But sine to the 4th is sine squared squared. Well, one of the Pythagorean identities says that sine squared plus cosine squared is 1. So sine squared becomes 1 minus cosine squared. Now at this point, just to make writing a little bit easier, let's go ahead and make a substitution. We're going to say u is cosine, which means du is negative sine. And so what this now becomes is antiderivative u to the 8th times 1 minus u squared squared du. Now, let's expand out the 1 minus u squared squared. That's 1 minus 2u squared plus u to the 4th. Right? We can now distribute that u to the 8th through. We'll get u to the 8th minus 2u to the 10th plus u to the 12th. Taking the antiderivative, u to the 9th over 9 minus 2u to the 11th over 11 plus u to the 13th over 13 plus a constant. If we distribute that negative through, negative u to the 9th over 9 plus 2u to the 11th over 11 minus u to the 13th over 13 plus constant. Now replace our u, right? So we get negative cosine to the 9th over 9 plus 2 cosine to the 11th all over 11 minus cosine to the 13th over 13 plus our constant. And that would be our antiderivative. Next, let's go ahead and take a look at the antiderivative of sine to the fourth times cosine to the fifth. Well, this time let's write cosine to the fifth as cosine to the fourth times cosine. Right? And now cosine to the fourth is cosine squared squared. And using the Pythagorean identity, we can write cosine squared as 1 minus sine squared. And once again, just to make the writing a little bit easier, let's just go ahead and use u sub right now. So let u be sine. So du would just simply be cosine x dx. And so what we get is now the antiderivative of u to the fourth times 1 minus u squared squared du. And I proceed in much the same fashion. Expand out that 1 minus u squared squared. Distribute through the u to the fourth. And now use power rule. All right, so u to the fifth over 5 minus 2u to the seventh over 7 plus u to the ninth over 9 plus our constant of integration. And now replace u, and we get sine to the fifth x over 5 minus 2 sine to the seventh x over 7 plus sine to the ninth x over 9, all plus our constant of integration. Let's now consider the antiderivative of sine squared times cosine to the fourth. Sine has the lower power here, right? So let's write sine squared as 1 minus cosine squared. Distribute the cosine to the fourth through, and we are left with antiderivative cosine to the fourth x minus cosine to the sixth x dx. And for simplicity, that's split down to two separate antiderivatives. And now we tackle each one of these individually. So let's go ahead and start with cosine to the fourth. So here we're going to use cosine reduction formula. We'll have 1/4 cosine cubed x times sine of x plus 3/4 the antiderivative cosine squared x dx. Now, what we could do is use cosine reduction again on the cosine squared, or use the identity of cosine squared equaling 1/2 the quantity of 1 plus cosine 2x. Here all I'm doing is factoring out that 1/2 so I can write 3/8 instead. Right, so antiderivative of x, of 1 is just x. Antiderivative cosine of 2x, this is a u sub. We're going to get 1/2 sine of 2x. And all this is, of course, plus some constant, which I'm going to ignore for right now. Now what we could do is rewrite sine of 2x. Right, so remember sine of 2x is 2 times sine x cosine x, so sine of 2x would be a half. Excuse me, a half sine x cosine x, or, I'm sorry, yeah, we're going to double it, right? Sine of 2x is 2 sine x cosine x, so this just simply becomes 3/8 sine of x cosine of x. Either one of these two would be acceptable. So that was cosine to the 4th. What about cosine to the 6th? All right, so what I'm going to do is, for purpose of this example, I'm just going to use that form. All right, so cosine to the 6th, again, we're going to use cosine reduction formula, and we can now write this as 1/6 cosine of 5x times sine of x plus 5/6 antiderivative cosine to the 4th x dx. Now at this point, there's no need to continue, right? We already figured out what the antiderivative cosine to the 4th is, right? We literally just did that. That is 1/4 cosine cubed sine plus 3/8 x plus 3/8 sine x cosine x. All right, we're going to get 5/24 cosine cubed times sine plus 15/48 x plus 15/48 sine of x cosine of x. Now what we do is we just subtract the two boxes, right? So we're going to subtract this bottom box down here from this top box, right? Because it was cosine to the 4th minus cosine to the 6th. Let's start with the x, right? So we're going to have 3/8 minus 15/48. All right. So we need to multiply by 6, right? So we get 18 minus 15. That is 3/48, which is 1/16. So x/16. Let's look at sine x times cosine x. Well, same in terms of the coefficient. Let's look at the sine x times cosine cubed. So I have 1/4 minus 5/24. Well, that's going to be 1/24. And we only have that one sine cosine to the 5th, so minus sine cosine to the 5th all over 6. Let's add our constant in now. And there we have our, there we have our antiderivative. All right, let's now look at antiderivative sine of 5x times cosine of 3x. All right, so here we're going to make use of product to sum identity. All right, we're going to have 1/2 antiderivative. Sine of 5x minus 3x plus the sine of 5x plus 3x. And now this is a fairly straightforward antiderivative. We get 1/2 negative 1/2 cosine of 2x minus 1/8 cosine of 8x plus a constant. And expanding that out, we're going to get negative cosine of 2x over 4 minus cosine of 8x over 16 plus a constant. Well, let's now go ahead and look at antiderivative of tangent to the 6th times secant to the 4th. Well, we can write secant to the 4th as secant squared times secant squared. And then using a Pythagorean identity, specifically the identity that tangent squared plus 1 is equal to secant squared, we would get secant squared x is tangent squared x plus 1. Now we can use a u sub. Let u be tangent so that du is secant squared x dx. And what this now becomes is the antiderivative of u to the 6th times u squared plus 1 du, which is the antiderivative of u to the 8th plus u to the 6th. Well, that antiderivative is u to the 9th over 9 plus u to the 7th over 7 plus a constant. And now plugging back in tangent, we get tangent to the 9th x over 9 plus tangent to the 7th, to the 7th x over 7 plus a constant. And finally, let's go ahead and look at the antiderivative tangent to the 5th x times secant cubed of x. Right, now here let's go ahead and write tangent to the 5th as tangent to the 4th x times tangent of x. Then we can write tangent to the 4th as tangent squared of x squared. I'm sorry, I forgot my dx there. And let's just move that tangent x so it's next to the dx. Well, tangent squared would be secant squared minus 1. And while I'm at it, I'm going to go ahead and write secant cubed as secant squared times secant. So that we can now say, let u be secant, which means that du is secant tangent. All right, so now what we have is the antiderivative of u squared minus 1 squared times u squared du. Expand out the u squared minus 1 squared first. We get u to the 4th minus 2u squared plus 1. Now distribute that u squared through. We get u to the 6th minus 2u to the 4th plus u squared. And that gives us u to the 7th over 7 minus 2u to the 5th over 5 plus u cubed over 3 plus a constant. And replace in our secant. And we have secant to the 7th over 7 minus 2 secant to the 5th over 5 plus secant cubed over 3 plus our constant.